can you solve this geometry challenge? Here's the question. Let's start with a square. Now let's draw a semicircle with a diameter of 10 units. Now let's draw a quarter circle with a radius of 8 units. Now from this point of tangency, let's draw a segment and let's call this as AB. And the question is, what is the length of segment AB? Now pause this video right now and see if you can answer this question, because I will show you the solution in 3, 2, 1. So given this figure, the goal is to find the length of this segment AB. Now, to answer this kind of question, what we're going to do is to consider all of the important points. Now, the first point is the point of tangency, the center of the semicircle, and the center of this quarter circle. Now, take note, when we draw a segment from the center of the semicircle to this center of the quarter circle, these 3 points are said to be collinear, and this is not hard to prove. And now, to find the value of AB, what we're going to do from this point A, let's draw a perpendicular line directly to this side of this square. Now take note, this is perpendicular, so we have here 90 degrees, and also this is 90 degrees. And to answer this question, or to find the length of the segment AB, what we're going to do here is to prove that these two right triangles are congruent. Now, to show that these two right triangles are congruent, if these two right triangles are congruent, then we can easily find the value of segment AB. And that's the goal. Therefore, to prove that these two right triangles are congruent, what we're going to do is to name first the important points. So let's point this C, this is D, this is E, and this is F. Now the goal is to prove that triangle BCA is congruent to triangle FED. That's the goal. And now the big question is how to prove that these two right triangles are congruent. Now let's focus on this point of tangency, and take note, when we draw a radius directly to the point of tangency or to the tangent line, the radius is perpendicular to the tangent line. So we have here a small right triangle. And then what we're going to do is to name the acute angles as alpha and beta. So alpha plus beta simply equal to 90 degrees. Now let's focus on this big right triangle. One of its angle is beta. Therefore, the other angle, acute angle, simply equal to alpha. For sure, because alpha plus beta adds up to 90 degrees. Now, how about on this right triangle? One angle is alpha, so the other angle simply equal to beta. Now, from here, we are now ready to prove that triangle BCA is congruent to triangle FED. First, side AC, this side AC, is equal to side ED. The reason is they are both the length of the side of the square. They are both equal to the length of the side of the square for sure. Next, so we can say that AC equals ED. Next, angle BAC is equal to angle FDE. They are both equal to alpha. Next, angle ABC simply equal to angle DFE. They are both equal to beta. Therefore, by AAS postulate, we can say that triangle BCA is congruent to triangle FED. Now, since they are congruent, we can say that segment AB equals segment FD by CPCTC, or simply congruent parts of congruent triangles are congruent. Now, going back to our figure, what we're going to do is to find how long is segment FD, and it's very easy to find because FD is just the sum of the radius of the semicircle and this quarter circle. Now, the radius of this quarter circle is simply equal to 8 units, and the radius of the semicircle is just 5 units. Therefore, FD is simply equal to 5 plus 8, and 5 plus 8 simply equal to 13. Therefore, we can say that AB equals 13 units. And that is our answer to this question. Therefore, given this figure, then the length of segment AB equals 13 units. And as always, we are done.